Hello students, welcome to my channel Chori Maths. Solution. Now, this question says that when you expand 1 plus px all raised to power n, you are going to get this. That is the first three expansion of 1 plus p, 1 plus px all raised to power n is going to give us 1 plus 2x minus 3x squared. Now, we are going to expand this. Now, this is what really happens in the expansion. This is going to be n combination 0, so that we have 1, we take all the power raised to power n. Then we have px all raised to power 0. Now, the second is n combination 1. Then we have p, not p now, we have 1 all raised to power n minus 1. The power reduces by 1, while this term, the power increases by 1. Plus, we have n combination 2. Then we are going to have 1, and it reduces further, this n minus 2. Then I have px all raised to power 2. Now, it is very important what I've done here. You see, most teachers will see this n combination 1, okay, n combination 0, sorry, as 1 straight ahead, and they will continue the work. It is very correct, but this is just showing in details what is actually happening. So let's go down. Now, 1 plus px all raised to power n combination 1, of course, n combination 0, sorry, is 1. Then 1 raised to power n is 1, that is, this is 1, this is 1, and this is 1. When they multiply themselves, this is going to be 1. Okay, plus I have n combination 1. Of course, this, the whole of this, okay, is equals to 1. And the whole of this is still is equals to 1. So I'm going to have it as, this is going to be px, then plus, I'm going to have n combination 2, then I have p squared and x squared. Remember, the first three terms is the same thing as 1 plus 2x minus 3x squared. So 1 plus n combination 1 px, then plus n combination 2 p squared x squared is the same thing as 1 plus 2x minus 3x squared. Now, just looking at them and comparing terms, you find out that the coefficient of x here is going to be equal to the coefficient of x here. So remember, I told you by comparing terms and coefficients. So we can come down to say n combination 1, then p will now be equals to 2. Okay? Now, if you have this, the second will be that the coefficient here, all right, must be actually equal to the coefficient of x squared here, right? So we can come down to say n combination 2, this time around p squared is equals to minus 3. Now, but you know, we have to do quick explanation to what combination is, okay? Now, if I have n combination r is having the expression n factorial all over n minus 1 minus r factorial, then we have r factorial. So it is not going to be difficult for us to pick the first one, so that I'm going to have n combination 1, which will now be equals to n factorial all over n minus 1 factorial, then 1 factorial. But don't forget that 1 factorial is still the same thing as 1. So we can now come down to say this is going to be n all over n minus 1 factorial, all of them, okay? Then p is equals to 2. Now, n factorial is n into n minus 1 into n minus 2, and it goes like that. Then this is going to be n minus 1, n minus 2, and it goes, then p is equals to 2. Now you can see that everything here cancels everything here. So I'm going to have np is equals to 2, and this is going to be my equation 1. Then I'll go quickly to the second, which is n combination 2. Now, n combination 2, then p squared is equals to I think minus 3. Good, minus 3. Now this is going to be n factorial all over n minus 2 factorial. Then I have 2 factorial is equals to minus 3. Now this is n into n minus 1 into n minus 2. Okay, all over I have n minus 2, then I have n minus 3. It goes and I have 2 times 1, that is 2 factorial. And this is going to be p squared is equals to minus 3. Now you could see that everything here cancels out, so that I'm going to have n into n minus 1 all over 2, then p squared is equals to minus 3. Now let me have it as n combination n minus 1, then p squared is equals to minus 6. That is when I cross multiply. And this is going to be my second expression. So let me put it as equation 2. Now from equation 1, which we said np is equals to 2, you can now see that p is equals to 2 over n. So I'm going to substitute it so that in equation 2 now, so that I'm going to have n into n minus 1. Then instead of p, I'm going to have 2 over n. Then all squared is equals to minus 6. Now this is n into n minus 1. Then this is going to be 4 over n squared is equals to minus 6. So I have n into n minus 1 times 4. Then all over n squared is equals to minus 6. Here 1 and here is n. So I have n minus 1 into 4 all over n is equals to minus 6. So this is going to be n minus 1 into 4 is equals to minus 6n. So I'm going to have 4n minus 4 is equals to minus 6n. So we have 4n plus 6n is equals to 4. I'm collecting like terms now, right? So we have 10n is equals to 4. So n is equals to 4 over 10, which is 2 over 5, which can be seen as 0.4. So I've gotten my n. But recall that we said p is equals to 2 over n. So p is now going to be 2 over, instead of n, I'm going to have 2 over 5. This is going to be 2 divided by 2 over 5, which is 2 times 5 by 2. So this cancels out. My p is 5. So in conclusion, I'm going to have my n as 2 over 5. Then my p is equals to 5. I've solved the question. So please guys, make sure you subscribe to my channel to continue to watch premium math videos. Thank you so much.